everyone, my name is Cindy von Haugg. I'm a Clemson Master's student here at the Kennedy Center, and the focus of my research is wood duck nest site selection and the relative abundance of suitable nesting cavities in coastal South Carolina. Wood ducks are one of the few duck species that are secondary cavity nesters, so when we're talking about nest site selection, we're referring to preformed tree cavities in primarily forested areas, something like what you see bordered in red. And they'll also nest in man-made nest boxes like the one you see bordered in yellow. These were created to mimic the look of a tree cavity, but although they'll readily nest in boxes, it's suggested the cavity nesting subpopulation accounts for 90% of duckling production. As you can imagine, conducting forest surveys to locate these cavities is one thing, but climbing every tree with a potential cavity to inspect it for suitability is a task all on its own. When done the conventional way, these surveys are ground intensive, they're time and resource consuming, and they largely lack practicality. When you add in the perils of the swamps in the southeast, it's not surprising that most cavity studies are completed in the northern regions. The problem is there's little overlap with the tree species in these regions and what we have here in the southeast. Better understanding where cavities occur in this region can further the ability to study the cavity nesting subpopulation and increase accuracy of population models. Bridging this gap is critical considering wood ducks garner economic importance as the second most harvested waterfowl species in 2 out of the 4 migratory flyways we have here in North America. My first objective was to minimize the time and resource requirements in order to maximize that practicality and thereby encourage continued studies of cavity occurrence. I felt the best way to do that was to eliminate the need to climb trees. So I developed a method that allowed me to measure internal and external cavity dimensions and therefore evaluate suitability safely from the ground. This method also increases accessibility to cavities on limbs like the one pictured here, or in trees otherwise unsafe to climb, as well as significantly reduce the time required to evaluate the suitability of each cavity. My second objective was to conduct forest plot surveys and use my method to identify potential tree and forest stand characteristics indicative of high cavity probability. I conducted 160 20-meter radius plot surveys within the 5 most common forest types in South Carolina and at both federally and privately managed properties. My third objective was to locate suitable cavities using radio-marked wood duck hens to assess cavity use versus availability, and after monitoring cavities, compare characteristics of cavities with successful and failed nesting attempts. Once I analyze which characteristics are potentially significant to cavity occurrence, I plan to use GIS software tools to generate maps similar to these ones, highlighting areas with high cavity probability. It's my hope that having these maps will best direct and encourage future studies so we can work to increase the accuracy of demographic vital rates and population estimates, and therefore best inform management practices for this important game species throughout the southeast region of their range. I couldn't go without acknowledging the following because without each and every one of them, none of this would be possible. Thank you.